Alright, I got a fun one for you guys today. This one is about animation. So we're finally going to try and do similar things that we've done in Scratch, but now in Python. Okay? So we're going to try and animate things. It's going to be exciting. So first of all, let us recap the functions, because functions are something that are very, very helpful to us as programmers, and we're going to be using them for the rest of our programming careers. Okay? So all a function is, it's just a rerunnable piece of code. So you say def the function's name, and then you can give it things that are variable. Okay? Give it little variables called parameters. This is parameter P1, parameter P2. You have as many as you want. Maybe just 2 is fine. And then you execute code with P1 and P2. Okay? That is the idea, okay? And these can change. You can call this in different ways, right? When you call it down in your code, you say func name. If only I could write letters properly, like 42 and 43, and then this code suddenly gets jumped to and is run with 42 getting the value, or P1 getting the value 42 and 43 going into P2. Okay, and that's how it works. And you can call this multiple times. You can say func name next time. Do the same thing, but with different values, like maybe x and y this time, whatever those are. Yeah? So that is a function. So it's just a rerunnable piece of code that takes parameters in the definition and arguments when you call it, and those arguments get filled in for the parameters. Okay, that's how this is all working there. So that is the idea, and sometimes we want to use our functions in like a bigger expression, like maybe we want to print out this whole thing or assign this to like z or something. We can do that if the function gives back an answer, if it gives back a value. Okay, so let's see here. Gives back a value with returns. Okay, so return y, for example, gives back y. Return, I don't know, true, gives back true to the user. Okay. So return is very important. Okay. So that just gives back a value, and that is the idea. So that is the point of returning. Sometimes you have another function like, I don't know, f2 over here that just takes 43 and maybe it like prints 43 to the screen. It doesn't really care about giving back an answer to be used in some larger expression. That's okay. It's okay if you don't want to do stuff like this. Some functions, they just do things for you and they don't need to give anything back. Okay? So like print, for example, that doesn't need to give anything back, versus like math.square root. This one needs to give something back so you can use it, and this one just needs to do that thing of printing for you. Okay? Hopefully that makes sense. So I'm going to show a bunch of functions in this lecture, and we're going to do cool stuff with them. Okay? So I want to first show you a draw rectangle function, and the first question I want to ask is, what should we be asking for? Like, how do you represent a rectangle? And one way to do it is give its upper left coordinate. Like, how do you like represent this exact rectangle right here? Well, one way to do it is to give its coordinate, like, I don't know, 1, 5, and then you give its width and height. Yeah? And so this is like, I don't know, maybe this is 4 and this is 3. This completely describes the rectangle. Yes? Does that make sense? And so you can pass along coordinates in Python using what are known as tuples. Okay, this is an example here of what's called a tuple. So instead of lists, if I go here, instead of lists, like the list 1, 2, you can say, and this is like L or something, instead of L, let's say T for tuple, 1, 2 with parentheses. And this makes a tuple. Okay, it's almost exactly the same as a list, but it looks a lot more like coordinates, so we're going to use those instead of lists. Okay, that's all a tuple is. It's just a type that holds a bunch of stuff similar to a list, and just like a list, you can get out the individual elements. So like if this is x, the tuple 1, 2, then you can get out the 0th thing, which was the 1. You can get out the 1th thing, which was the 2. Okay, so that is how we can represent rectangles and eventually draw them. Okay, so we're going to make a draw rectangle function, and so we need parameters. Okay, we are going to use this representation of a rectangle. So we're going to need all those things, right? We need a point that pins down where the rectangle is in space, so we'll use the upper left corner coordinates. And then we also need width and height. Okay, so this is what it's going to start looking like. Def draw rectangle, like UL for upper left, and then we need the width and the height. Yeah, and that's good enough for now. Later we can add like the color as well. So that is, yeah, that is the idea. So tuple, it's just another type like lists. Just think lists and replace all of the angle brackets with the parentheses. Okay, that is all. And so cool stuff needs to go in here that does turtle things. Okay, so maybe we need to go to this, go to UL turtle.up before that, and then turtle.down after that, dot, dot, dot. So we're going to fill all this with the rectangle drawing code, and this is a very good example of a function that just does something, because we don't need draw rectangle to give us anything back, we just need it to draw the rectangle on the screen. Okay, so let's do this. Let's make draw rectangle. I have made a nice empty file for us, and let us go and save it somewhere. So this will be lecture 23 then. And let's call it, perhaps, I guess let's just call it draw a rectangle. .py. So there we go. And let's do this. So we need definitely turtle, because we want to do turtle stuff. And what we'd like to do is something like, okay, let's draw this rectangle. Let's give it the parameters, like draw rectangle, like 1, 5, give it the width as 5, or whatever it was, 4, and the height is 3, and this should draw the rectangle for us. And we can do that multiple times. That's the beauty of it. So yeah, this is going to be, I guess, how we do it. So we'd like to say something like, and I'm going to make it bigger for us because the coordinates are quite small in the turtle land. Draw a rectangle. Let's start it at like, I don't know, -50, 100, and let's give it 200 by 150. Yeah, that can be our rectangle. So I'm going to say def draw rectangle, upper left, width, height, and then we need to do our code here to draw that rectangle. So how do we need to do this? I think the best way is to, like, okay, here's the rectangle we want to draw in space, and the turtle's way over here. Well, we first need to get him there, get him to the upper left coordinate, and then we can start going like in a little square. Okay, so I think that is the way to go. Let's do it like that. I think that should work. Okay, so let's break this down into comments. That's very helpful a lot of the time. So move the turtle to UL, then we want to face him east, and then let's go forward by width, right? Yeah, because we're going to be drawing this part of the turtle when we go width. When we first go right, that's perfect. And then we need to turn right 90 degrees, then forward height, and then again turn right 90 degrees, and then forward width after that. Okay, see how it's working? And then right 90 forward height once more. And that should draw the rectangle. Okay, so let's do this. So turtle dot up, or maybe we should make him a turtle first. And this needs to be a string. Yeah. There we go, turtle dot up, and let's face him. Oh, sorry, we need to first get him to UL. So how do we get these coordinates out of UL? Because it's a tuple. It looks like this. We need to get the x and the y coordinate out of this, so we can say 0, 1. See that? So we can say turtle dot go to, and then we give x and y. We can say UL of 0, UL of 1. That gets the x out and the y out. See that? That'll work. And then turtle dot down, and then we want to face him e. So turtle dot set heading, or set h to 0. 0 represents east, I think. We'll find out if that's not correct. And then forward width, and then right 90, and then forward, not width, but height, and then some more right 90s, and now I can start copying and pasting things. All right, so let's get the right 90s up in here. Those ones are easy. And then forward width and height. Okay, so I think that should do it. You see how we're taking these, we're giving these arguments to be filled in for these parameters, and then we're going to run this code with those values, okay? With these values right here, and let's see if it actually works. Whee! It looks like it did! Yay! That's exciting. So that is how we can draw one rectangle. We can, of course, draw many more. Maybe we can make a square down here. We can be like at negative 100, negative 150. We'll draw a 150 by 150 rectangular, maybe even smaller, 100 by 100. Yeah, so we can do this multiple times to rerun this code and draw new rectangles. Isn't that nice? So there's the first one, then we go over here and do the other one, which happens to be a square. Isn't that fun? And we can customize this as much as we want. We could say, like, okay, we could add a color parameter that could keep track of our turtle's color. So we can set the pen color, or the color, okay? That is the idea. So yeah, let's just set the pen color for now. We can change it to whatever the user passes along. We can say, okay, let's have a color parameter. And we can say that the color is, let's set it first. And then we can give different colors down here. We can say blue and red, for example. And so now we set the color every time we call this this function. And now we have a blue rectangle and a red, like a square. Isn't that cool? So rectangles are quite nice. And we can rerun this code as much as we want. That is the beauty of functions. Okay, so in the similar vein, let's make some resizable letters, because I'm sure if you followed my example, we didn't know functions before, and maybe you drew in your initials and your graduation year, just all hard-coded. Like there is LN, and there's like a 2 and a 0. That could be me when I graduated. So let's make it resizable. Let's be like, okay, let's give a width and a height, and we can draw our character in there, in this little bounding rectangle, and it will look like this. See that? That could be our L now. And if we wanted to draw it with a different width and height, we would just give a different values for those things. So draw an L that's really skinny. And just as easily, it could draw this one. See that? So let's make resizable letters with a width and height that are passed along to us. Okay, that's my next example. So let's do N, because N's a bit more complicated than L. Let's do this. So the idea is we can bound every letter inside a rectangle. Any N can be bound inside a rectangle. So here's my N, look like that, right? A big one, a skinny one, whatever you want, you can make your like extended and condensed fonts, if you would like. Okay, so let's do this. We want these to be like passed to us, a width and a height again, and we'll draw our and also an upper left coordinate, of course, and we'll draw, like, pretend there's a rectangle here, but use it to write our n. Okay, so yeah, given a rectangle to fill with a letter, we can draw any character inside there and have it take up all that space. Okay, so here is how we can do it. Here is how we can do it in code. So it's going to be like def draw n or something. It'll be like draw n with a certain ul width and height. And it's going to be very, very similar to the rectangle part. One of the things that we could do is like figure out these coordinates ahead of time. So here is like x and y that it starts at. And if this is width and this is height, we can find out these other coordinates quite easily. And it's probably a bit easier to use go-tos instead of like all the fancier stuff. So let's figure out what these are. This is xy. This is, well, we got to make this n, remember. So we need all these coordinates eventually. This is x plus w, y. This is x plus w, and then we have y minus h, I think. Yeah. And then this one is same x, but y minus h. Yeah. I think those are the 4 coordinates that we could use to draw this n. All right, so without any further ado, let's do this. Make a new file, and it'll be very similar. Draw n. And so instead of all this, maybe we can draw like n's instead. So I guess I can just keep a lot of this. It'll be very helpful to do that, I think. So instead of draw a rectangle, let's make it draw n. We can keep the color, because why not? So instead of draw a rectangle, it'll be draw n in this plot, in this plot. So again, we need to change the color, move the turtle. Now, let's use go-tos to do all this, okay? So first, we might as well get the x and the y out, yeah? Let's do that. Oops. We want this one. Let's get the x and the y out of ul, okay? That would make it easier for us. So x is ul's 0, y is ul's 1. And so I can keep them here, but we can be cool and use x and y now. And now we can draw the n. So I don't know the best way to put this. It's kind of in the way, isn't it? So that's what I want, okay? So we can start, let's start here. Let's start here and then go like that, yeah? So actually, let's be a bit different, okay? This whole thing is drawing the n, but this is going to be a bit more interesting, okay? So I guess let's start at, yeah, this one over here. So x, y minus h. Okay, so we're going to go there, and now we're down, okay? Now we're going to keep on going to places. The next place we want to go to, because we want to draw this line, is xy. And then we want to go here to draw this line, x plus w, y minus h. And then we want to go straight up, right? Turtle, I'll go to x plus w, y to draw this line. This one right here. All right, so I think that should draw the n. I would like to think that it will, but I could always have made a mistake, of course. Hey, look at that. Look at that. And let's, for good measure, let's draw one more that's super tiny. Like, I don't know, let's be a very small width. So like 15 and like 50 or something. and it can be black. Yay! So that's an n within an n, it seems. Let's change these coordinates around. Let's make it like 100, 150. Isn't this fun? So now we're drawing resizable letters. You can do this now. Isn't that cool? Maybe you want to go back and do your initials a bunch of times with a loop, even. So that's how you make a resizable n, and this is all practice using functions, right? And now we're ready. It's time for the main course. So we're going to animate a ball dropping, okay? Eventually we want it to look kind of like this with like real physics and stuff, but it's going to take us a second to get there, so it won't happen this lecture, but soon. So I would like to drop a ball in Python. We want to like have a little bounding place, and then here is my ball, and what's going to happen is we can start it somewhere and drop it, and then it'll keep on bouncing up and down, okay? It's very simple, I'm sure, but this is not easy to do in Python, okay? So it's going to keep on moving up and down like this, and keep on bouncing off the walls, okay? That's what I want. That's what I'd like to do, and it can start here at the top, maybe. And it's going to keep on going down and then back up, okay? So that is our dropping ball, that is our idea, and that is what we want to do, okay? So we are about to animate something in Python, and in Scratch we didn't have to think about this, but now we do, okay? We have to like code this up ourselves from the beginning and get philosophical, like what is animation, okay? So animation, like it's film, right? You got all these little pictures that are being shown to you quickly that makes you think that something is really moving, okay? So that is the idea. That is animation, and we have to do this ourselves in Python, okay? It was a lot easier in Scratch. It did it for us. Now we have to talk about like, okay, let's make all these little frames. Let's go between them. Let's move quickly between them, okay? So the idea is like we have our ball. It starts here, then we wait a little bit, and maybe the ball's now here. We waited a little bit more in time, and now the ball's here. That simulates movement. These are frames, okay? These are called frames. Every different image is called a frame. These are frames. Okay, and so we'd show them one after another. We go from that one to that one to that one. Yeah. And then it gets a little choppy, right? I'm sure you've like had a bad internet connection. You have been watching YouTube once, and like the video goes very, very slow and choppy, and it looks like there's like a strobe light, but it's daylight out. That is when there is a low frame rate, right? We like it for the images to change very quickly so that it looks like real life, okay? So when the images change faster, that means we have a faster frame rate, okay? So maybe we want to like show a new frame every 1/60th of a second, and then we have a 60 FPS frame rate, 60 frames per second, okay? I'm sure you have heard of those words before. So that is all about animation, and so that's what's going to give the illusion that this ball is dropping. We're going to like draw circles in different spots of our little screen and wait a little while between them, okay? So that's our frame rate, okay? So we're going to now make our ball. It's going to get dropped, and it's going to keep bouncing. It's going to be a little square that's going to bound it. So this is what our frame is going to look like. So we've got our little Python window, and then I'm going to draw a rectangle inside of it, and then a ball will start up here, and then it'll keep on dropping and going back and forth, okay? So there's going to be a rectangle, hint, hint, we can reuse what we already did, and then a little circle, okay? That is the idea. So it's going to be bouncing off the walls, and eventually we're going to make it look really cool and real by adding physics to like make it simulate gravity and things. But we're just going to move it a little bit now, okay? So thinking about frames, we want the ball to move just a tiny, tiny bit between them, okay? Just a little bit, move the ball slightly between these frames and do it quick enough it's animation, okay? That is the idea. We want to move the ball ever so slightly each frame. And the way to do that is by changing its y-coordinate, okay? So let me show you how to draw the ball. It's actually going to be the turtle. It's going to be funny. So let's make a new file. I'll call it like bounce or something. Here we go. And so import turtle. what I'd like to do is first let's make this bounding rectangle. Yeah, it's like the stage for us to play in. So, do I still have the other one open? Nope, I closed it. Let's go back. Recent files. Draw rectangle. There we go. Let's steal this. I guess all of it. And then we'll go to bounce. Replace. So, we're going to draw a rectangle. And that will be like our bounding rectangle for this screen that we're going to move the ball inside of. So let's draw a rectangle that's black, like at, I don't know, -200, -200, and it could be like 400 by 400 or something. That can be the width and height, and it can be black. Let's see if that's a good screen for us. Oh, nope, definitely not. We want it to be start at -400, -200, 200. How about that? Positive 200. Excuse me. Is that wide enough for us? I can be happy with that. Okay, so that's our little screen, and now we're going to draw a ball inside of it. Okay, and the secret is, yes, you can draw circles with turtles, which is fun. You can draw circles, but the easier way to do this animation is to actually use the turtle itself as the ball. Okay? It's weird, I know, but promise me it will make sense. Okay? So shape. Where is the shape? So down here there's a shape function on the turtle, and it can be arrow, turtle, circle, square, triangle, or classic. So we're going to make the turtle a circle. Turtle will be our ball. Okay? I'm sorry. Sorry, Mr. Turtle. We have to morph you into a ball now. So make the turtle into a ball. So turtle.shape is circle. Crazy. So after he's done drawing the screen for us, he is now a circle. Isn't that crazy? And the color of the turtle is the fill color. Okay, so we can make him like pink or something. Turtle dot fill color, right? Pink. Hopefully that was the right one, otherwise we'll look it up. Yeah, and this is tiny, so we can change his size as well. Okay, so we can say turtle dot turtle size. Yeah, we can stretch him, width and length, stretching. So we can say it like this. We can like turtle dot turtle size, like 2 to stretch him twice in both axes. Okay. So here's how we can do that. Ah, no. Go back. We were here. My silly mouse. I need to buy a new one. Okay. Here we are. Here we are. Okay. Turtle's now pink. Let's make the turtle larger. By doing turtle dot turtle size, and then stretch him on both axes. Stretch him twice in the x-axis, stretch him twice in the y-axis. Because if you didn't do that in both axes, he would look like an oval. Okay, 2, 1, make him look like an oval. See? There we go. So 2, 2, and I think that's a big enough ball for us. Now the issue is I have no clue how big this ball is, and we want to put the turtle like right here. Right? So we need to move him into the middle of our little bounds of our screen. So let's do that. Let's set the turtle up. And so the coordinates should be, let's pick him up as well. The coordinate should be, well, if this is, let's see, if this is -200, 200, and these are 400 by 400, this would be what? 0, right? It'd be 0, 200, I think. That's, this part right here is 0, 200. Let's confirm that by putting the turtle there. And now we're just using the turtle to move. Okay? Yeah. So the issue now is the turtle takes up space, and I don't know how big he is, honestly, so they're just going to have to play around. Maybe it's like 15 or 30 by 30, who knows. So let's get the turtle inside the box by like moving him ever so slightly. Let's figure out what the turtle's size is. So turtle width. Let's pretend it's like 30, and let's see if that was good. Okay, so turtle, please go down by turtle width divided by 2. Let's see if that was good enough. Okay, so it wasn't 30, it might have been 40. Let's see if that was it. It was 40. And then we'll subtract half his length, so we're inside the box. Yeah! Okay, so it was apparently 40, okay? That was the correct turtle width. Okay, so now the turtle is within the bounds, and we want to move him ever so slightly, okay? That is the idea, okay? So here's how we do it. We're going to, the animation is going to be done for us just by moving the turtle, okay? And that's going to be our next frame, just moving the turtle. It will animate for us, okay? What we're going to do is change the turtle's current y coordinate to be a little bit different each frame, okay? More or less, I should say. And then we have to figure out when he hits the ceiling, okay? So he's going to start moving downward, and we're gonna do it like this. So like turtle x, we can start that at 0. Turtle y, it can be whatever it was, that like 200 minus width thing. And then we want to change the turtle's y a bunch, okay? So we're going to say like turtle offset or something. Give him a little offset, and offset him by like, I don't know, -5 each time. Let's try that. And then we're going to keep on doing repeatedly do like turtle y, change the y, like plus, or turtle y equals turtle y plus turtle offset. Sorry, that says offset. So this will keep on changing its y and then redraw the turtle. Redraw. I hope you see the idea. If it's not clear yet, in the code it will be. Okay, let me show you this. So here's what we want to do. So repeatedly, we want to do the following. Let's get the turtle started. So let's start his x at 0, turtle y at this fancy thing, 200 minus turtle width over 2, because that seemed to work. And if we want to use that variable, it needs to be defined up here. There we go. And so now, yeah, we want to go to the first spot. Turtle go to turtle x, turtle y, and let's make the turtle speed very quick. Just so that it's easier for us to do stuff. So now nothing has changed, and we just drew it quickly, getting the turtle in the right spot. And now we're going to repeatedly do stuff. So the forever loop in Python is while true. Okay, forever, do the following. Okay, what we want to do is take the turtle and offset him a little bit. Offset the y coordinate just a little bit. Make the offset -5 for now. Okay, so here's what we can do. Forever, change the turtle's y coordinate to move him slightly. Redraw the turtle at the new location. Because turtle x and turtle y will keep track of where we want the turtle to be. Okay? When we move the y coordinate for the ball down a little bit, then we're going to redraw the turtle in that new location. Okay? So it's like turtle x and turtle y are our model for where we want the turtle to be, and then we still have to use goTo to actually move the turtle there. Okay? So let's change the turtle's y coordinate by saying turtle y equals, well, whatever it was, plus the offset. Yeah? And then we're going to redraw the turtle at that new location. So all we have to keep saying is turtle.goTo, turtle X, turtle Y. See that? So move him a little bit, redraw him. Repeatedly, forever. Do that, okay? Move him a little bit, redraw him. Move him a little bit, redraw him. Okay, I hope that makes sense, and that is all we need to do to animate him. Okay? Eventually, we're going to need to worry about the ceiling, but that is for later. Whee! You see him? Look at him. Isn't that fun? And he's just going to fall off the screen right now because we're moving him down there, we're redrawing him down there, but we can't see down there. Yeah. So you can rerun the program as much as you want. Isn't that fun? Looks like he's falling. So we need to bounce him off the bottom. Okay? So we need to bounce the turtle sometimes. Okay? And the best way of doing that is right here. Okay? Check right here. Check if we hit a wall. Okay? That is the idea. So if we hit a wall, we need to like change the turtle's direction so that we don't continue into that wall. Okay? That is the hope. So if we hit a wall, we need to figure out what to do. Okay? So we hit a wall when the turtle's y coordinate is way up here or way down here. Okay? So let us make those variables for ourselves. So let's say like top wall, the top's y coordinate is this, because we started him at the top. And then the top, the bottom y coordinate, we know he's at the bottom if his y coordinate is negative 200 plus turtle width over 2, okay? Because that's just the bounds of this rectangle. Okay? So if he's ever like past the top or below the bottom, we need to like change his course, okay? If turtle y is ever greater than or equal to, or I guess greater than, top y, then let's move the turtle down to like the top again. We don't want him to go out, because here's what would happen. If we didn't do that, and the turtle, like, his animation frame sent him way up here, we don't ever want to draw the turtle up here. We want to, like, if he ever tries to go up here, we want to, like, morph him, teleport him right back down to there, okay? So if he ever tries to go too high, let's move him down to the top again. So, turtle y equals top y. See that? That's the idea. And then we also want to change his direction. This is easily done with our offset now, because negative was bringing him down, positive will bring him up. So let's just re-change this offset by -1, okay? That's the beauty of it. It'll work in both cases. We can do the same thing, because we can just multiply it by -1 to be the opposite one. Direction equals direction times -1. So I'm negating this offset. So -5 was bringing it down. If I negate it, it's now going to be +5 and bring the turtle up. Isn't that cool? So that's for if the turtle hit the top wall, and we can do exactly the same thing if he hit the bottom wall. Very similar. Okay, so otherwise, if the turtle's y is less than, if you try to exceed the boundaries of the bottom y, then we need to move the turtle up to the top, or sorry, up to the bottom, if that makes sense. And then also change the direction, because he was moving down, he needs to move up. See that? So it'll just be the negative offset. And I'm sorry I said direction when I should have been saying turtle offset this whole time. Excuse me. Sorry. It is customarily called direction. So that's why I got a little tripped up. So now that is all we need to do. Check if we hit a wall and bounce off. And yeah, that's essentially it. All we have to do forever. This is all we need to do to animate the turtle. So try to move him a little bit. Move him a tiny, tiny bit for our frames, right? Move him from here to here, things like that. Like change this frame to this frame. And eventually, he's going to get to the bottom, okay? So if the turtle's y ever, if he gets to the bottom, he's going to get to the bottom the first time. If he ever tries to go past the bottom, in his direction with his offset. Then we are going to teleport him back up to the bottom because he shouldn't have gone outside. And then we're going to change his offset so that the next time we come back into this loop, he's now going in the opposite direction. You see that? That's the key. And the same thing happens if he hits the top. We're going to bring him back down inside of the screen again, and then change his offset so that the next time he goes in the new direction, the opposite direction. Okay? And this go-to is just, again, always changing the turtle's location to animate. Okay? And so the idea is the turtle is moving so quickly, as fast as this loop can go, we're moving the turtle, and that is causing the animation to take place. Isn't that fun? So, we have a perfectly bouncing turtle now. And the turtle is pink. And secretly a ball as well. So, I do encourage you to study this code. It's a fun little exercise. It's a lot, I know. But it's really, really rewarding to get this working. I think you can agree. Yeah? So now we're finally animating something in a style similar to Scratch. Isn't that nice? So yeah, we just have a bouncing ball right now, going up and down, up and down. So that is, I think, what I want to do. Actually, one thing that we could do is make a random starting x coordinate if we wanted to. Why not? How about that? Random starting coordinate? Question mark? We could do that. That's quite easy. We can say import random. And we can say something like, well, the turtle's x, it doesn't have to be 0. It can be like, instead of 0, let's start the turtle's x at a random location. So like, I don't know, turtle x equals random.rand int, like, I don't know, negative 100 and 100. So he's still within the bounds, but like he's moving around a little bit. So then he's starting a little bit over there. And that wasn't very different, now was it? If I change it again, now he's there. Let me rerun it while he's working so I can show you the difference. Yeah, so now he's over there a little bit. Rerun. Isn't that fun? So we can move over there now. That's the idea. Okay, so that's just an easy thing that we could do. And it's helpful for your next programming assignment. So this is our fun program, and I encourage you to study this. You're going to be using a lot of this code, so definitely go and take a look at it. Understand how it's working. You're going to use this in your programming assignment. Okay, so here's your next programming assignment. What you will do is you will edit this code to be similar yet different. Okay, so let me make this large for you. What you're going to do is use turtle and random again to do the following. Okay, these two things I've already done for you. So you're going to draw this bounding square to represent the walls, and then make the animated ball, which is the turtle, go up and down. And then you are going to randomly make weird things happen when the ball hits one of the walls. Okay, so for example, when the ball hits maybe the bottom wall, you could be like, I'm going to change your color to something random. Okay, that's the idea. Change the color to a random one. You can change the size of the ball, like by a factor. You can use random.uniform if you'd like. That will get you a float instead of an int, so it's like 0.6 or something. That's a possible result. And yeah, that's the cool, fun stuff. So maybe you can like teleport the turtle, change its x coordinate within the bounds of the screen, of course, to like once he hits the top wall, move him over here, just for fun. Move him to a random x coordinate. Yeah, you can also change the speed of the ball by a random factor, and the speed is dictated by this offset, right? So we could change his speed to be faster or slower by changing how big this offset is. So like if I can make it 10, the larger the absolute value of the offset, the faster the turtle. So now he's going to move by negative 10 units at a time. So now he's going real fast. Crazy turtle. I can make this negative 5 again. Yeah? For it to be a bit more leisurely. So that's how you can change the speed. Yeah, you can also randomly change like the shape of the turtle to be something other than the circle. He's got other shapes, right? It could be a triangle if you'd like. So that is fun stuff that you could do. You have to pick some stuff, okay? Oops. So yeah, what I'd like you to do is make a new function, okay? Because I'm testing your knowledge of function making. Call it like do something weird or something like that, and it's going to randomly pick some weird thing to do, okay? Each time the ball hits a wall. And so you can like hook into it down here and be like, okay, if it hit a wall, maybe I'll call this function. I'll call this function somewhere, yeah? That's what you can do, okay? These are like the places where you check if it hit a wall. If it did, call your function, do something weird, and have it do one of these weird things or something that you think of. Okay, so I want you to program at least 3 different weird things that get to be chosen from when this function gets called. Okay, so your function needs to pick one of those things to do randomly each time. Okay, so hopefully that's fun. Do yell at me if you have any questions. Again, just upload a video, and I want to see your ball bouncing on the top and bottom wall and doing cool, weird things whenever it hits one of those walls. Okay? Change the color, change the size, the speed, etc. So that is the idea. Definitely use all this code, copy and paste it as a starting point, and then you're going to add your function and get it to do weird stuff. Okay? So that is that. Please, please ask me if you have any thoughts about anything, if anything's not making sense. And I think that's all I have for you. So good luck with this, and I will see you next week.